Today we're implementing a system that allows our characters to procedurally walk. Welcome to the Prototype series, a group of videos in which we'll explore creating small projects combining differing Unity features. This project will extend our previous Procedural Boss prototype and walk you through the setup for a procedurally animated bipedal character using the animation rigging package. If you're interested in diving deeper and learning more, we have a longer training session on our Unity Learn website, and you can find a link to it and this downloadable project in the video description. This video will walk you through the creation of our prototype, setting up a rig with the animation rigging package, creating a script to procedurally animate that rig, and then integrating it into our original scene. Let's get into it. We started by downloading the original Procedural Boss prototype, which included assets for a two-legged robot walker and the animation rigging package pre-installed. The model for our robot walker includes multiple skin meshes and a hierarchy of transforms called the rig or skeleton. In the context of 3D animation, the skin mesh plays the role of the skin or visible surface of the model, and the rig or skeleton is composed of bones, which are objects which can cause the skin to follow their movement and the form, much like the bones in the human body. To better visualize this hierarchy in the scene view, we can use the bone render component provided by the animation rigging package. For this, we select the first object in our bone hierarchy and in the animation rigging menu choose Bone Render Setup. Now we can see all of the bones that make up the rig for our character in the scene view. Normally, character animations are created by setting keyframes for different poses of this rig. The benefit of the animation rigging package is that we can dynamically control the rig using different constraints, allowing for flexible and dynamic animations. To create constraints for our rig, we started by selecting our character and choosing Rig Setup from the animation rigging menu. This automatically adds the rig builder and animator components to our character, as well as a child object named Rig1 that will act as our rig layer. Organizing our rigs into layers allows us to stack multiple rigs if we desire. In this case, we're using a single rig. Any constraints we add to this rig layer will be automatically added to our rig. Constraints in this context can be thought of as rules for how our character rig is allowed to move. An important concept for this type of animation is that of inverse kinematics, or IK for short. IK allows us to control a chain of bones, for example an arm or a leg, and to cause them to be positioned and rotated to follow a target, like an apple held at the end of that arm, or in our example here, a foot. This allows us to decide where the end of a chain of joints should be and have the rig position the other joints in the chain automatically. For the legs of our walker, we use the 2-bone IK constraint, which dynamically solves the rotation of our leg given a target position for where we want the foot to be placed. To do this, we only needed to set up the tip transform, and then right-click on the component and choose Auto Setup from Tip Transform in the drop-down menu. This created a target and a hint game object that we used to control the leg. The target object acts as a position of the foot, and the hint object tells the leg in what direction to bend. In order to procedurally animate the legs, we created a script which controlled the position of the target. First, we needed to fix the target position of the foot to the ground. We used a downward raycast to find a position on the terrain for our foot to go. Notice with this done, we can move the body, but the feet stay in place. Our goal for this character is to be able to move the body either from player control or from an AI script and to have the feet reposition themselves procedurally. To do this, we needed to find the next foot placement once the body had moved. We used the new position of the body to send another raycast down towards the terrain. If the new position found by the raycast was over a certain distance from the previous one, it's time to take a step. We used interpolation to move the target from our previous position to our new one, and we also used a sine curve to add an arc to our step. Right now the legs move at the same time, so we offset the initial position of the feet and added a check to only animate when one foot is on the ground. We now have a fully procedurally animated character ready to be put back into our scene. With a little bit more code to follow and look at the player, the robot walker is complete. If you want to download and try out this prototype yourself, you can find it via the link in the description below. There's also a link to the Unity Learn website, where you can find a longer training session showcasing the features used to build this prototype. Thank you so much for watching, and I'll see you in the next one.